Hello everyone. In the last video we learned about variables and data types in C++ and Java programming. So variables are basically the storage units used for storing data, and data types specify the type of data to be stored inside the variable. Later on we saw that every particular data type has different sizes. The smaller the size, the smaller is their range. The larger the size, they have larger range and can store large numbers inside them. So let us have a look at the range of those data types. Let us have a look at first Java programming. We saw 8 primitive types: byte, short, int, long, float, double, char and boolean. This is the size in bytes. Byte is 1 byte long, which is 8 bits, ranges from -128 to 127. Short is 2 bytes, which is 16 bits, ranges from -3 to 768 to 3 to 767. So there is a way of remembering these ranges. What we can do is 1 byte is 8 bits. So the value ranges from negative of 2 to the power 7 to positive 2 to the power 7 minus 1. 2 to the power 7 simplifies to 128. So negative of 2 to the power 7 gives us minus 128, and 2 to the power 7 minus 1 gives us 128 minus 1, which is 127. Similarly, we have short, which is 2 bytes. Therefore, it would be 16 bits long. Its value would range from negative of 2 to the power 15 to 2 to the power 15 minus 1. For int, we have 4 bytes. So 4 8s are 32. It would range from minus 2 to the power 31 to positive 2 to the power 31 minus 1, which gives us a very large number here. For long, we have 8 bytes, which is 64 bits. So the range would be negative of 2 to the power 63 to 2 to the power 63 minus 1. For float and double, we have a mathematical notation here which specifies 3.4 followed by decimal values e plus 38. So this is a mathematical notation. E refers to 10 to the power something. So e plus 38 refers to 10 to the power 38. So we have a range from negative 3.4 into 10 to the power 38 to positive 3.4 into 10 to the power 38. This was the case for float. Similarly, for double, we have this range negative of 1.7 into 10 to the power 308 to positive 1.7 into 10 to the power 308. This was for double. This is a very large number, and we would probably use double wherever we need more precision in our answers. Char for storing a single character, which is 2 bytes, and boolean can store either true or false. This was the case for Java, and this is the official documentation of Java programming. You could refer to docs.oracle.com if you want to have in-depth understanding of what particular data type does and want to know about it in more depth. So you could find the official documentation on docs.oracle.com for Java programming. For C++, we have a documentation here from Microsoft. We have various data types in C++. Int, similar to Java, occupies 4 bytes in memory, and it has the same range as that of Java, as it occupies 4 bytes. In C++, we will see a lot of data type classified as signed and unsigned. So what this concept does is, signed refers to negative range as well as positive range. Now if we want to do some computation which deals with only positive values, then we could specify that particular data type as unsigned. So what exactly unsigned does is, the negative range is truncated and that particular range is extended to positive side of the range. So here we have an int which was signed by default. If we do not specify unsigned before it, by default the variable would declared would be of signed. So we have ranges on both negative part and positive part on the real number line. If you declare the same variable as unsigned int, then what it will do is, the range will reside only in the positive part of number line. The negative parts get truncated. So let us check the value. The negative range extended from 2, 1, 4, 7, 4, 8, 3, 6, 4, 8 plus the positive range 2, 1, 4, 7, 4, 8, 3, 6, 4, 7. So this gives us 4, 2, 9, 4, 9, 6, 7, 2, 9, 5, which is exactly same as this number from 0 to this particular number. So what we are doing is, without occupying more memory inside of our memory, we are using the same variable by having larger range. Given that we know that we would be computing only positive values, all the computation will be happening in positive numbers. And we have an alternative to this int, where int underscore int 8 occupies only 1 byte. This is similar to byte data type in Java, the term byte which we have seen here. If you want a variable which can store integers but want to shrink its range, then you could specify this data type. Then we have an underscore int 16, which is a 16-bit integer variable, so it will be 2 bytes and its range is 327682 32767 from negative to positive. We have an unsigned 16-bit integer and so on. We do have a 64-bit integer which would occupy 8 bytes. Then we have a bool. Bool can store either true or false, occupies only 1 byte in memory. Char, for storing a single character, occupies only 1 byte. Unlike Java programming, it occupies 1 byte, whereas the char of Java occupied 2 bytes. So this is one of the difference. Then we have short, which is 2 bytes, same as that of Java. And you could see we have a very long list of them. You could refer. Float, similar to that of Java, 4 bytes, double 8 bytes. 3.4 into 10 to the power 38, both on negative as well as positive side. Then we have double 1.7 into 10 to the power 308, both on positive as well as negative side. Now float gives us the precision up to 7 digits and double gives us the precision up to 15 digits after the decimal point. And in majority of the cases it is recommended to use double if you want more precise answer than that of float. Now let us have a look at few examples and basic concepts of the programming. So here we have two files, display.java and display.cpp. This is the basic skeleton of a Java program. You have to make sure that your every program includes this particular skeleton. The only thing which differs in program is the class name, which is same as the source code. If you name your source code as display.java, then the class name should also be display. Alright, so let us have a look at how to produce output on the console. For producing output, we have a print statement written as system.out.print followed by a pair of brackets and a semicolon. Then if you want to print a particular static message, then enclose that message within double quotes and write a message. Suppose my message is this is a message. What it exactly does is, whenever it encounters this print statement, this will print the contents enclosed inside the brackets. And inside of our brackets, we have a static message enclosed inside double quotes. So we would get an output, this is the message on the console. So go to the folder and open up a terminal there. Compile the Java program by JavaC compiler followed by name of the file javac display.java. This would produce a bytecode known as display.class. Then interpret that class file by Java interpreter. So we get an output as this is a message. So this was one of the ways how we produce output in Java. We have another version, println. What it exactly does is, first of all print whatever the message is specified and then shift the cursor to the next line. So here in previous case when we use print instead of println, what it did was, this is the message was printed and Vivek at Vivek HP, all the stuff was appended just beside it. In this case, we have used println. So what it will do is shift the cursor to next line. So in this case, this entire line would be shifted to the next line. First we compile it and then we interpret it. As we have used println, we have a trailing new line character at the end of the statement. Now let us have another example. Suppose if I say system.out.print and my message is first line. In this case, first system.out.print first line, it won't break the line into second line. It would continue to print this is a message behind first line and then break line. So what exactly happened is first we use a print statement, therefore we did not have a new line break after that. Whereas in the second statement we have used println, therefore we have a break line after this is a message. If I shift the order, then it would produce the output in two different lines. But the last line won't be broken. Therefore this particular line would be appended behind the second line. So the first line would contain output, this is a message. Second line would contain the output first line followed by this data. So the first line has the message, this is a message, broke the line, and the second line has the data, first line as well as Vivek at Vivek HP notebook and so on. So this is how we print static messages. Now comes the case of how we print variables. Let us assume a variable. So we have data type int followed by variable val equals to some particular value. Let us assume 20 and print it as val. This is how a variable is printed in Java. Just simply write the name of the variable whose value is to be printed. So this case produces simple output of 20 as a number. So println had a variable val which was printed and later the line was broken as the function's name is println. If I had used print, then you could guess what the output should be. Vivek at Vivek HP notebook is appended right after the program's output. Now suppose if we want a message to be printed along with the variable. Now 20 doesn't make sense, right? So we could append a message like the value of variable is equal to plus val. So here comes the use of concatenation operator. Concatenation is used to concatenate multiple messages together. So first is a message which is static. The value of variable is equal to which is fixed plus val. This is placeholder for this value 20. So we get an output value of variable is equal to 20. Wait, I forgot to save the file. Alright, we compile and interpret. So we get an output, the value of variable is equal to 20. So we could concatenate as many data as we want. Suppose if I add a full stop behind the value, then I could also use concatenation again, and within the double quotes I use a full stop. Let us clear the terminal, again recompile and interpret it. So we get the value of variable is 20 and you could note full stop here. This is how we produce output in Java. Now let us have a look at program in C++. So this is the skeleton which you have to remember each and every time. And hash include iostream using namespace standard int main and a return 0. So for producing output on the console, we use cout and two angle brackets, and similar to Java we have double quotes for string in C++ as well. This is a message from CPP file and end the statement with a semicolon. Now we compile the file using G++ compiler, G++ followed by name of the file which is to be compiled, which is display.cpp. This produces an executable code a.out. We can execute it as dot backslash, which specifies inside of the current directory a.out. On execution, we get this particular message. This is a message from CPP file. So as soon as we execute this file, this statement is executed. This is a message from C++ file and we get the output. In case of C++, for having a new line, we can use an escape sequence \n. So this \n is a special character, also known as an escape sequence, which conveys some special meaning to compiler and is not printed directly onto the console. So what it exactly does is, whenever the compiler comes across a special character, it finds out its meaning and acts accordingly. So \n is used for breaking line. So first of all, this is a message from CPP file would be printed and then the cursor would be shifted to the next line. First we compile it and then execute it. So the last time, after getting the output, this was appended behind our output, whereas in this case the character is \n character helped us in shifting the cursor to the next line. Therefore we have Vivek at Vivek HP notebook on the new line. So this is how we can break the line in C++. If you want to concatenate data in CPP, then you could use multiple angle brackets. A pair of two angle brackets, or you could say less than operator, is used for concatenation. Now suppose if I say val, then I have to declare a variable integer val equals to 20, and this is a message from CP. Let us change the message. The value of variable is colon, and let us remove \n from here and keep that \n at the end of the message. So what it will do is, the value of variable is colon followed by 20, and then it will break the line. So we get an output, the value of variable is colon 20. Compile and execute. The value of the variable is colon. This is the static message enclosed within double quotes. Then we have concatenated val 20 followed by a new line to break the line and shift the cursor into the next line. So this is how we produce output in our C++ code. Now let us have a few examples about mismatching types, and then we'll see an example to swap two values and perform few arithmetic operation. So mismatch type, what it exactly means is, if I try to store a value, let us change the data type to byte. Remember, byte in Java has a range of -128 to +127. Let us try to store +150 inside it, which is out of its range. Therefore the compiler, JavaC compiler, would throw an error on us that incompatible types, possible lossy conversion from int to byte. As 150 does not reside in the range of its permissible range, we get this particular error. Same way, if we go beyond the range on the negative side, -200, we would get the same error. -200 incompatible type, possible lossy conversion. So the thing is, we have to make sure we are always within the range of the specified data type. If you are unsure and you think that the variable might exceed this range, then it is recommended you use large data types like int or long. Now let us have a look at how to store character. For character, we have a data type char followed by a variable. Let us name it ch. Char equals to a particular character. Now a character is always enclosed within single quotes. Single quotes. Suppose if I want to assign character A, then A has to be enclosed within single quotes. So the character A would be assigned from right hand side to variable ch, and then value of variable is plus ch. So what it exactly does is prints the character out on the console. The value of variable is equal to a. Right, now what if I try to assign directly equals to a? Now how compiler refers to this statement as a is a variable whose value is to be stored inside variable ch. So let us declare another variable a, which is initialized to variable value z. So what exactly happens is a is initialized to character z, and in the next statement we declare another variable ch, which is initialized to variable a. So a is containing value z, so z would be assigned to ch. The value from right hand side always gets assigned to the variable on the left. So what we get in the output is value of variable is z. The value of the variable is z. Suppose if I comment out the first statement, then it would give me an error. Cannot find symbol. So this is an error for a variable. It is considering a as a variable, not as a character. Alright, if you want to consider a particular character as a character in programming, then you have to enclose it within single quotes. So this is how characters are represented in Java. Now let us take the case of strings. String st equals to some particular value. Now as characters are enclosed within single quotes, the strings are enclosed within double quotes. Like in the print statement, whatever we saw here was a string. So we could use that same message and store it inside a particular variable. So string st is a variable which is initialized to the value of variable is equal to, this is the value which is stored inside variable st. And in the print statement I could directly write st, which is placeholder for this particular string, st plus ch. Now let us take char ch equals to a. So we get an output, the value of variable is a followed by a full stop. So we get the particular output. So this is how strings and characters are declared. The way characters are written is to enclose them within single quotes, and strings are always enclosed within double quotes. Now let us have a look at float and double data types. Float, well, let us assign value of pi. Now whenever you refer to a float value, you always append f behind it to specify that a particular type is a float. And let us have a message, value of pi is 3.14. So compile, interpret, value of pi is 3.14. For double, what we could do is append d behind it and change the type to double. So you won't be finding any difference between float and double in this case, as double has a larger range than that of float. But this, I am just representing how to represent literals, that a double value is represented by appending small d or capital D, and float value is represented by appending small f or capital F. Both of them are applicable. So we get value of pi is 3.14, but in this case this value was stored inside a variable whose type was double. Alright, now let us have an example in which we have two variables, integer n1, let us initialize it to 15, and we have another variable n2 initialized to 30. Now if I just print them, then I get output as 15 space 30. First of all I am printing 15 followed by a space and followed by another variable which is 30. Now the aim of our program is that after the execution, after the logical part, n1 should have the value of 30 and n2 should have the value of 15. Alright, so if I try to assign value of n2 into n1, what will it do is n1 equals to n2 means the value of n2 would be assigned to variable n1. So after this statement, the value of n1 gets changed to 30 and the value of n2 gets remains unchanged, which is 30 itself. So we get an output as 30 30, right, which is not what we want. So what we could think of is take a temporary variable and have a temporary copy of n1 stored inside it, then store the value of n2 inside of n1. So after this statement, we have n1 equals to 30, n2 equals to 30. n2 is unchanged, but n1 is changed to 30. Also remember, a temporary copy of n1 is stored inside a variable named temp. So if we want to assign the value of n1, we could access it from the variable temp. So we could write n2 equals to temp. Temp had the original value of n1. So value of n1 is basically indirectly assigned to variable n2. So in this case, we'll get output as n1 space n2. In this case, the output would be 30 space 15. Compile and interpret. Wait, I forgot to save again. Compile and interpret. So we get 30 space 15. Now let us have a look at arithmetic operations. We'll have this program in CPP. Now we have 5 arithmetic operators: plus, minus, multiplication means asterisk, division, and a modulo operator. So let us declare two variable. n1 is 10 and n2 is 35. Let us declare another variable ans, which is initialized to n1 plus n2, and we display a message addition equals to ans followed by a new line, semicolon. So what it exactly does is declare two variables n1 and n2 to and initialize to 10 and 35. Then declare another variable answer whose value is the simplified version of n1 plus n2, which is 45, and display a message addition equals to answer, which is 45, and then break the line. So remember how we compile a C++ program: name of the compiler followed by name of the file, then ./a.out gives the output addition equals to 45. Now let us have a look at the other four operations. No need to declare this thing again, as once it is declared, we do not need to declare it again. First we perform addition and then we perform a subtraction. Subtraction equals to, then we perform multiplication with asterisk operator. And for division we use slash operator. Division equals to this. So what is expected output? 45 is assigned to ans, and then we have already performed addition, right? So we have modulo left here. Modulo operator is used for getting remainder. First of all, we perform an addition operation and print it. Addition equals to ans. Then modulo operator, what it exactly does is perform the division of n1 and n2, and whatever the remainder is left is returned back to the variable. So if I have used n1 as 10 and n2 as 35, it will give me a remainder of 10, because 35 zeros are 0 and we have a remainder left of 10. So let us have a look at the output. Addition is 45, remainder is 10. Subtraction is minus 25, 10 minus 35 is negative of 25. Multiplication 35 times the 350, and division is 0. Now why is division showing 0 is because we have used the data type as int. So what it exactly does is n1 by n2 simplifies to something 0 point something. Now if the data type is one of the integer type, then the decimal part is truncated and the integer part is always written. So 0 point something, whatever the decimal part is, that would be truncated, and 0 as an integer would be written. Therefore we are receiving output as 0. Now if I do n2 divided by n1, which is 35 by 10, so we get an answer of 3.5, but still the output in this case would be 3, as the decimal part would be truncated. We compile and then produce the output. We get division answer as 3. Also, if I shift variables from modulo operator n to modulo n1, which is 35 modulo 10. So 35 on dividing by 10, the quotient is 3, 10 3s are 30, leaving back the remainder as 5. So we get remainder equals to 5 in this case. So we get remainder equals to 5. So these were the 5 basic arithmetic operations. Try to implement the arithmetic operations in Java by yourself and this swapping example in C++. And if there is any query, please let me know in the comment section. Thank you.